Good afternoon, class. We are looking at trigonometric identities and equations, double angle and half angle formulas, solving trig equations. So we covered trigonometric equations and identities, sum and difference formulas, and now double angle and half angle formulas, solving trigonometric equations. The objectives are to use double angle formulas to find exact values, use double angle formulas to establish identities, use half angle formulas to find exact values, use double angle formulas to solve equations. Again, reminding you of fundamental identities because we are going to use them. The functions, every trig function is a periodic function. The period is 2 pi for all of them except tangent and cotangent is pi. All of them are odd functions except cosine, therefore secant is also even. And the fundamental identities that we have seen, such as Pythagorean identities, quotient identities, reciprocal identities, and now sum and difference formulas. Sine of alpha plus beta is sine of alpha cosine beta, cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. We should be very comfortable with those. More formulas are coming our way. Now, 7.3 and 7.5, double angle and half angle formulas. Here's the summary. For double angle formulas, sine of 2 alpha is 2 sine alpha cosine alpha. Cosine of 2 alpha has 3 formulas, cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared alpha. Tan of 2 alpha is 2 tan alpha over 1 minus tan squared alpha. Now, they will give rise to the following. Sine squared alpha comes from here in this formula. You can solve for sine squared alpha. You get 1 minus cosine 2 alpha over 2. And therefore, if you divide the alpha by 2, this becomes alpha over 2. This becomes 2 alpha becomes alpha. From this formula, if you solve for cosine squared, you get 1 plus cosine 2 alpha over 2. And if you cut this in half, then you have to cut this in half. In other words, if 2 alpha is represented by x, then alpha is represented by x over 2. Okay. Tan squared alpha is 1 minus cosine over 1 plus cosine 2 alpha. Basically, tangent is sine over cosine. And if you want to go with half angle, tan squared of alpha over 2, you replace the 2 alpha with alpha. Half angle formulas. So if you want sine of alpha over 2, it's the same thing, take a root plus minus. Cosine, the same thing, take a root plus minus. Tangent, you can look at this one, okay? In this case, alpha over 2, this one, and take a root plus minus, or sine alpha over 1 plus cosine alpha, or 1 minus cosine alpha over sine. This is the summary of the formulas we are supposed to learn in this section. I'm going to look at the proof. So we start with sine of 2 alpha equals 2 sine alpha cosine alpha. So basically, we use the sum and difference. Remember, sine of alpha plus beta has this formula. What if we change the beta to alpha? That becomes sine of alpha plus alpha, which means if I use alpha instead of beta, I got to change this one to alpha. I'm going to change this one to alpha. This is sine alpha cosine alpha. This is cosine alpha sine alpha. They are identical. Becomes 2 sine alpha cosine alpha. Believe it or not, that is the proof. We want to prove cosine of 2 alpha is cosine squared minus sine squared, or cosine squared alpha minus sine squared alpha. We do the same thing. Cosine of 2 alpha is cosine of alpha plus alpha. So look at this one, cosine of alpha plus beta. If I change this to alpha, becomes cosine of 2 alpha, and I change this one to alpha, this one to alpha. So cosine of 2 alpha is cosine of alpha plus alpha. And according to this formula, cosine of alpha cosine alpha minus sine alpha sine alpha. I hope you see that what we are doing again. We are changing this beta to alpha, and that's what we are getting. Which means it's cosine squared minus sine squared. Now, cosine to alpha, we can represent it 3 different ways because we can change sine squared to 1 minus cosine squared. If we do that, so cosine squared minus this. So if I subtract this from cosine squared, I get minus 1 plus cosine squared. So replace this here. Minus 1 plus cosine squared. Therefore, we get 2 cosine squared alpha minus 1. But if we use cosine squared equals 1 minus sine squared, in other words, take it back to this one, replace this here, 1 minus sine squared, and another sine squared makes it 1 minus 2 sine squared. So one more time, this one, the proof comes from here. This one, once you replace the sine squared with 1 minus cosine squared, remember sine squared plus cosine squared equals 1. And once you replace it with cosine squared, very simple. Now, if I want to solve for sine squared here, what happens? I can take it to this side. I want to just quickly show you how fast you can solve for sine squared now. So if I move this to this side, I get 2 sine squared. I move this one to this side, I get 1 minus cosine alpha. Divide by 2, and you're done. Two sine squared plus 1 minus cosine to alpha, divide by 2. Now, what if we want to solve for cosine squared here? Let's move this to the other side. So 1 plus cosine of 2 alpha is 2 cosine squared alpha. So divide by 2. So 1 plus cosine to alpha divided by 2 is cosine squared alpha. These are some of the formulas we saw in the summary. And I want to show you how fast you can come up with the answer. And of course, we got the sine squared, we got the cosine squared. What is tan squared? Tan squared is sine squared over cosine squared. So if we divide this one by this one, I hope you recognize that this will be the numerator, this will be the denominator, and the denominator of 2 cancels out. So it's very straightforward. So we got a bunch of improved. Now over here, if I want to go with alpha over 2, this changes to alpha. In other words, let 2 alpha be x. So this is x over 2. So tan squared of alpha over 2 is 1 minus cosine alpha over 1 plus cosine. This one, if I change this to alpha over 2, I change this to alpha. So cosine squared of alpha over 2 is 1 plus cosine alpha divided by 2. Same thing here. Sine squared of alpha over 2, this one becomes alpha. It's a very simple proof, everybody. Tan of 2 alpha is a 2 tan alpha 1 over 1 minus tan squared alpha. We want to prove that. And all we have to do, use this formula, tan of alpha plus beta. If I replace this with alpha, that means anywhere you see beta, you have to change it. So tan of alpha plus alpha in this formula goes tan of alpha plus tan of alpha. So you're replacing the beta here with alpha. Replace it with alpha. Replace it with alpha. Replace it with alpha. So you get 2 tan alpha over 1 minus tan squared. It's that simple. Now look at these 3 formulas we had in the previous page. So if we want cosine is plus minus the square root of this piece, sine of alpha over 2 plus minus the square root of this piece, and the same thing here. So cosine alpha over 2 plus minus the square root of 1 plus cosine alpha over 2. Sine of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 2. And tan of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Please understand that basically over here to find the tangent, we divide this one by this one. Okay, divide this one by this one, and we get this one. So the synopsis of that, sine of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 2. So cosine of alpha over 2 takes a plus sign here. Tan of alpha over 2 is plus minus the square root of 1 minus cosine over 1 plus cosine. And tan of alpha over 2 is sine of alpha over 1 plus cosine alpha. Let's look at more proof so we understand what's going on here. All right. So we continue with the proof where plus minus sign is determined by the quadrant of the angle alpha over 2. Okay, that's how you come up with the answer here. So we say tan of alpha over 2 is plus minus this thing. And now we want to look at these two actually and see how we come up with those. So sine squared alpha over 2 is 1 minus cosine alpha over 2. If I multiply by 2, I get 1 minus cosine alpha. And now tan of alpha over 2 is sine over cosine. Sine over cosine. The sine of alpha over 2 over 2, sine of alpha over 2 over cosine of alpha over 2. Now let's multiply. Here's the trick to show you why we have this. Let's multiply the top by 2 sine alpha over 2, which means we're going to multiply the bottom by the same thing, resulting in 2 sine squared alpha over 2 for the top, and 2 sine alpha over 2 cosine alpha over 2 for the bottom. We remember sine of 2 alpha is 2 sine alpha cosine alpha. Therefore, sine of alpha is 2 sine of alpha over 2 cosine of alpha over 2. So what do? 2 sine squared alpha over 2, we're going to replace it with this one. So this, everybody will replace this one. This, everybody will replace this one. We get 1 minus cosine alpha over sine alpha. So we prove tan alpha over 2 is this. So if we multiply by the conjugate of the numerator, that means 1 plus cosine alpha, and we divide by it, the numerator becomes 1 minus cosine squared. The bottom is sine times 1 plus cosine. And as you know, this is sine squared, which means cancels out. This one gives us sine alpha. And that's the last one. We just proved this one. And this one, we had proved it previously. The point is, it can be easily proved. We just want to make sure that everybody's following the concept. All right. Now let's put them into a good use. Use double angle formula to find the exact values. If sine theta is 3 over 5, and theta is between pi over 2 and pi, which puts it in the second quadrant, find the exact value for sine 2 theta, cosine 2 theta, and so forth. So, for example, sine 2 theta, we know is 2 sine theta cosine theta, which means what? I have the sine theta, I need to find cosine theta. And I'm going to go with the Pythagorean identity and say cosine is plus minus 1 minus sine squared, and plug in 3 over 5 here. Now, of course, this makes it 9 over 16. 1 minus that makes it 9 over 25, 160. 9 over 25. 1 minus that is 16 over 25 comes out as 4 over 5. So plus minus 4 over 5. Now, cosine this is quadrant 2, and quadrant 2 is negative. Okay, quadrant 2 cosine is negative. So now plug it. So you have 2 times sine is given, cosine is found, and 2 times 3, 6 times 4, 24. So minus 24 over 24. Cosine 2 theta. Now you can use any of them. You can say cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared, because we have the sine and cosine. If we didn't have this and just had the cosine 2 theta class and sine, we didn't have to go anywhere. All we had to do 1 minus 2 sine squared. You follow what I'm saying? We wouldn't have to evaluate that. Now that we have it, it really makes no difference. If you square this number, you get 16 over 25, and let's just write it down. 16 over 25, and this one 9 over 25, and it results in 7 over 25. So cosine 2 theta is 2 minus 2 sine squared theta, and theta is somewhere between 0 and 2 pi. Okay, so in the first complete revolution. All right, so let's change cosine 2 theta. Since the right side involves sine squared, then we have 3 choices. We are choosing 1 minus 2 sine squared because this one has it. And so what happens? These two are identical. Don't move them. Just get rid of them. And we know 1 is not equal to 2. Therefore, this is the letter phi, which represents an empty set. That means no solutions. Okay, everybody, empty set. No solutions. Sine 2 theta plus cosine 2 theta is 0. Whenever you have sine and cosine, there are two methodologies. One is to square both sides and solve them. The other one, because you have, if you have other things special, because you have only sine and cosine, move one of them to the other side, divide both sides either by sine or cosine to make it into a tangent or cotangent. So the technique is to divide by that. If I divide by cosine 2 theta, what happens? The left side becomes tan of 2 theta. And the right side is simply -1. So it's pretty straightforward, everybody. So because it's, if it were 1, would be power 4, but it's -1 is 3 power 4. And I'm going to write it plus n pi. Here's the reason. There are, remember, in a from 0 to 2 pi, there's only 2 solutions if we then have a multiple angle. When we have a multiple angle, the methodology is to write it in this fashion. Divide both sides by 2. If I divide this one by 2, this one by 2, this one by 2, I get 3 power 8. Theta is 3 power 8 plus n power 2, and n is 0, 1, 2, 3. In other words, you stop at 4, because if you do 4, class, 4 times power 2 is 2 pi, so it gives you beyond a complete revolution. And for example, if I put 0 is 3 power 8. If I put 1, pi over 2 is 4 pi over 8, and 3 pi, 7 pi over 8. And you can figure out the rest. So between 0 and 2 pi, theta is 3 pi over 8, 7 pi over 8, 11 pi over 8, 15 pi over 8. Okay. And again, if you go beyond that, basically for tangent and cotangent, you find the smallest angle, in this case is 3 pi over 4, and then you add n pi, and then whatever this number is, you multiply it by 2 and you subtract 1 to stop. 2 times 2, 4 minus 1. Okay, if it was, let's say 3, 2 times 3, 6 minus 1, you would stop at 5. And if you don't, if you continue, you recognize 4 will take you beyond that. Okay, everybody. Example 3, establish identity, write cosine to the power of 4 theta in a format that does not involve powers of sine or cosine. So cosine to the power of 4 is cosine squared to the second power. So that's how you get rid of the powers. And you know cosine squared, and we want to just deal with cosine, by the way. Cosine squared theta, cosine squared alpha is 1 plus cosine 2 alpha over 2. So cosine squared of theta is 1 plus cosine of 2 theta divided by 2. We raise it to the power of 2. To raise this to the power of 2, first, understand this is 1/2. So 1/2 to the power of 2 is 1/4, and then deal with that. So 1/4. This raise it 1, 2 times 1 times cosine 2 theta, and then raise it to the power of 2. So one more time. This 2 makes this 1/4 apply to everything. And then raise the top to the power of 2. 1 squared is 1, 2 times 1 times cosine 2 theta, and then cosine squared 2 theta. What am I using? Okay. Now, everything is fine. So we can apply the 1/4. Everything seems good, except this guy has cosine squared, and we want to change that. So it's cosine squared alpha, we get 1 plus cosine 2 alpha over 2. Imagine this is alpha or x. So you can use this one. So let's say it's x. So just this part becomes 1 plus cosine of 2x divided by 2. That means 2 times 2 theta. Please understand. Just ignore the fact that this is 2 theta. Imagine it's x. So you need 2 times x. Think about it this way. So this is x, this is x, or better yet, alpha if you want. Now, this one is fine, this one is fine. 1/4 and 1/2 is 1/8. So 1/8 times 1 plus cosine of 4 theta. So this part, let me actually. So this part, like I said, the first two doesn't change. 1/4 times 1/2 is 1/8, and 1 plus cosine of 4 theta. Now, when we apply the 1/8, this becomes 1/8, this becomes 1/8 of cosine 4 theta, and 1/4 and 1/8, this is 2/8. They add up to 3/8, the rest remain unchanged. So pretty straightforward, everybody. Solve the trig equation. Cosine 2 theta, cosine theta minus sine 2 theta, sine theta equals 1/2. You may recognize it comes from the sum and difference. If you write cosine alpha, cosine beta minus sine alpha, sine beta, and you follow that, there seems to me that 2 theta acts like alpha and theta acts like beta. So this is cosine of alpha plus beta, everybody. Then this must be cosine of 2 theta plus theta. One more time. If you look at this formula, that's what we put here. So this is cosine of alpha plus beta. This must be cosine of 2 theta plus theta, which makes it cosine of 3 theta. As you know, for 1/2, the answer is pi/3. And 2 pi minus pi/3, 5 pi/3, because never mind this one, you can even think of it as cosine x. This gives you the reference arc of pi/3, because cosine of pi/3 is 1/2. So in the first quadrant is positive. In the fourth quadrant would be 2 pi minus pi/3, so 5 pi/3. So pi/3 plus 2k pi. And 5 pi/3 plus 2k pi. How do we get this? Again, I want to make sure we understand this one. You get 2 pi minus the reference arc, because it's in the fourth quadrant. That's why. Now, why are we adding 2k pi? Because it's a multiple angle, everybody. So you divide by 3, this becomes pi/9, this becomes 2k pi/3, the same thing here, and this becomes 5 pi/9. Now, if you want the answer from 0 to 2 pi, then you let k be 0, 1, and 2. If that was the question, this case 0, 1, 2, this case 0, 1, 2, and you get for the answers. Because it's 3, then you get 3 times 2, 6 answers in 0 to 2 pi, as I mentioned. Projectile motion, example 5. An object is propelled upward at an angle theta, where theta is between 45 degrees and 90 degrees. It's a parabolic, format. To the horizontal with an initial velocity of v sub 0 feet per second. If air resistance is ignored, the horizontal distance r that it travels is given by r equals 1/16 v sub 0 squared sine theta cosine theta. Show that this r is 1/32 v0 squared sine 2 theta. It's pretty straightforward, this part. We know sine of 2 alpha is 2 sine alpha cosine alpha. So this part is half of sine 2 theta. The product of these two is 1/32. And it's very simple proof. Find theta to maximize r. So if r is 1/32 v0 squared sine 2 theta, and this number is fixed, v0 is the initial velocity, it's fixed. So what can you do to this? Sine will become maximum when its argument is power 2. So when 2 theta is power 2, it becomes 1. So sine 2 theta equals 1 if it's power 2, and theta must be power 4. So the maximum occurs when sine 2 theta equals 1. It's pretty straightforward, everybody. All right, we are going to move on. Use a half angle formula to find the exact value of sine of 22.5 degrees. Well, we know it's another. You find a common arc. That's the idea. This is half of 45 degrees, so sine of 45/2. And we are going to follow this. Sine of alpha/2 is plus minus a squared of 1 minus cosine alpha/2. And 22.5 degrees is in the first quadrant, everybody, and therefore positive. This belongs to the first quadrant. And in first quadrant, all trigonometric functions are positive. So plus minus becomes just plus. Square root of 1 minus cosine alpha/2. That means cosine of 45 degrees. And cosine of 45 degrees, everybody knows, is square root of 2/2. And so this is a complex fraction. If you multiply the top and the bottom by 2, what happens is that 2 times 2 is 4, comes out as 2. And this one When you multiply it by this one, you get 2, and this one cancels out the denominator. So 2 times 1 is 2. This one cancels out the denominator. 2 times 2 is 4, comes out as 2. Square root of 2 minus square root of 2 over 2. This is an exact answer, not using a calculator. How about cosine of 5 pi over 12? You recognize this as half of 5 pi over 6. So cosine of 5 pi over 6. And notice that 5 pi over 6, cosine of 5 pi over 12 also belongs to quadrant 1. Because remember, 6 pi over 12 is pi over 2. Plus 6 pi over 12 is pi over 2. This is a little bit less than that, so you should know that. So it's in the first quadrant, everything is positive. So cosine of 5 pi over 6 divided by 2. And therefore, plus minus, for cosine, we just go with the plus, square root of 1 plus cosine alpha divided by 2. And 1 plus cosine of 5 pi over 6. Now, cosine of 5 pi over 6 is the same as cosine of pi over 6 because the reference arc for 5 pi over 6 is pi over 6. So it's the same as cosine of pi over 6, which is square root of 2 over 2. But is it positive or negative? This is the second quadrant where cosine is negative, so minus. One more time to see why this is negative. 5 pi over 6, its reference arc is pi over 6. So the value numerically is the same as that one, which is square root of 3 over 2. You have to figure out the sign based on the quadrant. This is quadrant 2. In quadrant 2, cosine is negative. We do the same thing, multiply 2 by 2, 2 over 2. This 2 is 4, comes out as 2, and this one makes this one 2, and this goes away. So we get the square root of 2 minus square root of 3 over 4 as the final answer. It comes out as 2 again. You don't have to write this. That one is good enough. Over here, I don't have to show that. I'm showing you here just in case if anybody is interested to see what happens. In case we don't get it. 2 times 2, 4 comes out as 2. It's that simple. Use half angle formulas to find exact values. If cosine alpha is negative 1 over 5 and alpha is between pi over 2 and pi, find the exact value of the following. These are half angles. So the very first thing is the quadrant, pi over 2 to pi. Half of this is pi over 4, half of this is pi over 2. And the half angles end up being in the first quadrant. The half angles are all positive. One more time. We want half of alpha. So we divide everything by 2. And we notice we end up in the first quadrant where everything is positive. So for sine, we use this one with a positive. 1 minus cosine, well, replace the cosine with negative 1/5, make it plus 1/5, and therefore the numerator is 6 over 5. And so I hope you recognize 6 cancels out the 2, and it becomes 3 over 5. And we rationalize by multiplying by 5 over 5. So this comes out as 5. This remains inside as square root of 50. For cosine alpha over 2, we use the same thing with a plus. That means this formula, square root of 1 plus cosine alpha over 2. And therefore, we use the same thing, but with a plus sign. The result is that we are subtracting 1 over 5 from 1, resulting in 4 over 5. 4 cancels out the 2, gives us 2 over 5 under the red. And now, just like this one, we are going to rationalize everything. Times 5 over 5, these two give us 5, and that gives us square root of 10. We are done. Everybody's happy. Now, As far as the tangent is concerned, I can use one of these formulas. But an easier way, tangent is sine over cosine. So divide this one by this one. One more time. I can use these formulas. But seriously, if you have already done the sine and cosine, don't waste your time with that. If you haven't, let's say the question asks, what is the tangent? You don't have this one. You don't have this one. Then you must use this. But since we have it, just the ratio of the two is the answer. Sine alpha over 2 over cosine alpha over 2. And of course, the denominators cancel each other. We get square root of 15 over 10. And I hope you recognize you can write this as square root of 15 over 10 and then square root of 3/2. You can recognize that as one root. So let's multiply this one by square root of 2. This one by square root of 2. The bottom is 2 and the numerator is square root of 6. Very straightforward. I hope everybody is fine with that. Given cosine alpha is negative 3 over 5 and alpha is between pi and 3 pi over 2, we want to find sine of alpha over 2, cosine of alpha over 2, and tan of alpha over 2. So we cut this in half. It gives us pi over 2, and this one gives us 3 pi over 4, which means quadrant 2. So the very first thing, you have to figure out, this is the given. You want with half of alpha, therefore divide this one by 2 pi over 2, this one by 2 alpha over 2, this one by 2 3 pi over 4. You know, when you divide a fraction by a number, you multiply that number by its denominator. And alpha over 2 is between these two numbers. That puts us in the second quadrant. In the second quadrant, sine is positive, cosine is negative, tangent is negative. So sine, use the formula with the positive. So we are using the formula. We're not going to write the formula again. Just square root of 1 minus cosine alpha over 2. This makes it plus. Makes it 8 over 5. 8 over 5 divided by 2 is 4 over 5. I can take the 2 out. And then if I multiply this one by square root of 5 over square root of 5, I get 2 square root of 5 over 2. So pretty straightforward, everybody. We are going to do the same thing here, but cosine is negative. We are going to use minus the square root of 1 plus cosine alpha over 2. So we're going to put minus the square root of 1 plus negative 3 over 5 divided by 2. So what happens? 1 minus 3 over 5 is 2 over 5 divided by 2 is 1 over 5. And don't forget, we have a negative sign here. We keep it. And so we can separate the top from the bottom, and we can multiply by square root of 5 over square root of 5. And we get minus square root of 5 over square root of 5. That's, again, pretty straightforward. I hope everybody is fine with that. Now, what about the tangent? As I mentioned before, I'm not going to use this formula class. The reason I'm not going to use it because I had to find sine and cosine, so I'm going to divide sine by cosine. That would be faster and easier, everybody. That would be faster and easier. Of course, they cancel each other. So we get 2 square root of 5 over minus square root of 5. Square root of 5 from the top and the bottom cancel each other. The answer is minus 2. Now, if you want to use this formula, you can, and you will end up with the same answer. However, this is a lot faster because we have worked hard to get there in the first place. So very straightforward, everybody. Establish identity. Sine of 4 theta is cosine theta times 4 sine theta minus 8 sine cubed. You can start from any side you want. For example, if you start from the right-hand side, RHS, right-hand side, we start from the right-hand side. Notice we can factor out the 4 sine theta from the parentheses. So if I take the 4 sine theta out, this gives me 1. This gives me negative 2 sine squared. So what is this? This one is 4 sine theta cosine theta. If 2 sine theta cosine theta is sine 2 theta, then this must be 2 sine 2 theta. And as you know, 1 minus 2 sine squared is cosine of 2 theta. So we have 2 sine 2 theta cosine 2 theta. Think about it as alpha. Imagine this is alpha. So the answer is sine of 2 alpha. 2 times 2 theta makes it sine of 4 theta, which is the left-hand side, and that's a proof, believe it or not. ln of cosine equals half of ln of 1 plus cosine 2 theta minus ln 2. I'm going to remind you of logarithmic properties. To do so, I'm going to start with the right-hand side. So I start with the right-hand side. Here's the logarithmic properties that you have seen from before. And log x base b of log base b of x equals y. That means b to the power y equals x. Log 1 base b is 0, so on and so forth. I hope you're comfortable with that. So I'm looking at the inside here. And I'm going to go with number 6, the quotient rule, and I'm going to go to the left. So that means ln of this over 2. So ln of 1 plus cosine 2 theta divided by 2. Then I look at 1/2 and I go with number 7. Number 7, when you have a power, this is called the quotient rule, this is the power rule, this is the product rule. So with the powerful, n becomes a coefficient. So the coefficient can become the exponent. So I can take the 1/2 inside and make it the exponent. 1 plus cosine 2 theta over 2 to the power of 1/2. And we know this is cosine squared. Remember, cosine squared alpha is 1 plus cosine 2 alpha over 2. So this is cosine squared theta. Now, cosine squared theta being raised to the power of 1/2 becomes simply cosine theta, and ln of absolute value of cosine theta, which is the left-hand side, and that's a proof. This is the same as this one. That's the proof. So of cosine theta plus 5 cosine theta plus 3 equal to 0, and we are interested from 0 to 2 pi. So we are going to change the cosine such that it involves cosine. So in other words, there are 3 different ways of writing it. We're going to go with this one. So 2 cosine squared theta minus 1. We're going to replace this with 2 cosine squared theta minus 1. And so this is 2 cosine squared theta plus 5 cosine theta plus 2. Factoring, because this is 2 and 2, both of them prime numbers, it's very simple, becomes 2 cosine theta plus 1 times cosine theta plus 2. I'm assuming nobody has any problem with factoring. Which means what? Cosine theta is negative 1/2, cosine theta is negative 2, and first and foremost, we get rid of this. Cosine is between negative 1 and 1, and it can't be. Now, negative 1/2. First, let's go with cosine theta equals 1/2 to find the reference arc, which is pi over 3. So your reference arc is pi over 3. Now, negative 1/2, cosine is negative in the second quadrant, so pi minus pi over 3 gives you 2 pi over 3. And in the third quadrant, pi plus pi over 3. That's how we get these two. So again, when cosine theta is positive 1/2, that gives rise to the reference arc. Okay, so subtract this from pi, you get 2 pi over 3, add it, and you get this one. I hope everybody is comfortable with that. Establish the identity for sine u cosine u times 1 minus 2 sine squared is sine 4u. We're going to start with the left-hand side. It's more involved. We can see that this is 2 sine u cosine u would be sine of 2u. So this is 2 times 2. Therefore, 2 sine 2u, and the second piece, obviously, cosine of 2u. So we have 2 sine, let's say, alpha, cosine alpha. 2 sine alpha cosine alpha is sine of 2 alpha. Sine of 2 alpha. Which means sine of 2 times 2u or sine of 4u. That's a proof. We want to prove cotangent theta minus tan theta over cotangent theta plus tan theta is cosine of 2 theta. Generally speaking, when you want to go with tan and cotangent, from cotangent and tangent to sine and cosine, just change them accordingly. So the left-hand side, cotangent is cosine over sine, tangent is sine over cosine. That's how we begin. Clearly, the common denominator is sine theta, cosine theta. You can multiply the top and the bottom by it, or just take a common denominator. So this becomes cosine squared minus sine squared over sine theta cosine theta. This becomes cosine squared plus sine squared over sine theta cosine theta. I hope you recognize it. Because the denominators are identical in a complex fraction, you can drop them. So it becomes cosine squared minus sine squared over cosine squared plus sine squared. Now cosine squared plus sine squared can be replaced by 1. And so the answer is cosine squared minus sine squared. Cosine squared minus sine squared is cosine of double angle, cosine of 2 theta, and that's the proof. Show that the area of an isosceles triangle, A equals half of S squared sine theta, where S is the length of one of the two equal sides, and theta is the measure of the angle between them. So this angle is theta, this side is S, this side is S. We know the area is half of base times the height. So all we have to do, figure out the base and the height. So this is the base, by the way, and this is the height. This whole thing is the base. So this is half of it, base over 2. This is theta, so this is half of it. This angle, this is theta over 2. And this is a 90-degree angle. So all we have to do, evaluate the sine and cosine, and there you have it. Sine of theta over 2. What is the sine of this angle? I'm looking at everybody. Let me do this. I'm looking at this one, okay? Let's say the right half. The right half. So it becomes clear what we are dealing with. So this is the angle theta over 2. Sine of that is the opposite, which is b over 2 over the hypotenuse, which is s. So if you multiply this one by this one, by the way, b over 2 divided by s, I hope you realize this times this one is b over 2, or b is this times this times 2. So I hope you can go from here to here, okay? So b is 2s sine theta over 2. We're going to do the same thing with cosine, and cosine of this angle is the adjacent h over the hypotenuse s, and therefore the hypotenuse is the product of these two. Hypotenuse is s times cosine of theta over 2. So we are going to replace it here. 1/2, the base, we will put this one, the height, we will put this one. So 1/2, the base is this, the height is this. And so so we have 1/2 2s sine of theta over 2 s cosine of theta over 2, which means we have 1/2 s and s is s squared. We keep the 2. We're not going to get rid of the 2. 2 sine theta over 2 cosine theta over 2. Why do we do that? Because we should recognize this according to this sine of 2 alpha, sine of 2 times theta over 2. This means sine of theta. This is sine of theta. And that's the proof. All right, we are going to move on. And now a rectangle is inscribed in a semicircle of radius 1. Semicircle, radius 1. with one of its side on the diameter of the semicircle. Express the area as a function of theta. So it's very straightforward, everybody. We know that the area is length times the width. So what is the length here? This is x, this is x. So the length is 2x. The width is y. So 2x times y. Now, let's figure out what is x, what is y, and we are looking at this triangle. This is a 90-degree angle. This is angle theta, and we know this distance is, because the radius is 1, we know this distance is 1. So we plug in 1. This distance is 1, okay? Because this is also the radius. So sine theta is y over 1, and cosine theta is x over 1. Sine theta is the opposite, y over 1, and the cosine theta is the adjacent, x over 1. And so we can replace the x with cosine, y with sine. So 2 cosine theta, sine theta. Show that a of theta is sine 2 theta. Well, this is the definition, actually. We proved the double angle. 2 cosine theta, sine theta is sine of 2 theta, just based on this formula. Find the dimensions of the rectangle. To get maximum area, also find the maximum area. Well, the maximum area happens when the sine is maximized, and the sine is maximized when it's equal to 1. That means 2 theta, the angle must be pi over 2, which means theta must be half of that, pi over 4, or 45 degrees. So what are the dimensions? X is cosine theta, or cosine of pi over 4. Y is sine of pi over 4, and both of them are square root of 2 over 2. Now, please understand that. That means the width is square root of 2 over 2, but the length is 2 times that, okay? Because area is 2 times x times y. It's 2 times x times y. And I hope you recognize the numerator. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. Divide by 4. We get 4 over 4, or 1. Develop a formula for sine of 3 theta, and we are going to go with sine of alpha plus beta, and we write sine of alpha cosine beta, cosine alpha sine beta. So one of them is theta, one of them is 2 theta. That's how we are going to develop it, everybody. So sine of 3 theta is sine of 2 theta plus theta, and in this formula, change the alpha to 2 theta, so this becomes 2 theta, and beta to theta. So we get sine 2 theta cosine theta plus cosine 2 theta sine theta. We are going to replace the sine with 2 sine theta cosine theta. This one we're going to keep, and we're going to change this one to cosine squared minus sine squared. So one more time, sine 2 theta is 2 sine theta cosine theta. Cosine 2 theta is cosine squared minus sine squared. So let's see what we get here. We get 2 sine theta cosine squared theta. What do we get here? Plus sine theta cosine squared minus sine cubed sine theta cosine squared, sine theta cosine squared. These two add up to 3 sine theta cosine squared theta, and minus sine cubed remains. In some cases, they stop here, but we can change the cosine squared to 1 minus sine squared to make it all a function of sine. So 3 sine theta times 1 is 3 sine theta, times this one becomes minus 3 sine cubed. So one more time, multiply these two, 3 sine theta minus 3 sine cubed. This is also sine cubed. They add up to 4. So 3 sine theta minus 4 sine cubed theta. Use double and half angle formulas to find the exact value. We know sine theta is 1/6 and theta is between 0 and pi over 2. Find the following. And we just follow the formulas. So in this case, we see that it's 2 sine theta cosine theta. Because we have sine theta, we have to calculate cosine theta. And remember, this is in the first quadrant. So we calculate cosine theta using plus minus the square root of 1 minus sine squared. And when we plug in, 1/6 squared is 1/36. 1 minus that is 35. So 35/36, or plus minus square root of 35/6. And we use the positive only. Why is that? Quadrant 1, everything is positive. So just plug in now. Okay, quadrant 1. So you plug in and you get 2 square root of 35 divided by 36. However, you can just say 2 is gone and this is 3. And you have the answer as square root of 35/18. Since we have, for cosine 2 theta, we really can use any of these formulas. The cosine squared, for example, minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1, because we have 3 different formulas. Since we have developed the cosine, perhaps we use that one. So square this one minus square that. And as you can see, this becomes 35. This becomes 1. 35 minus 1 is 34/36. 34/36 simplifies to 17/18. Sine of theta over 2, obviously both of these are positive because the half angles, this is in the first quadrant, half of it is in the first quadrant also. So using sine theta over 2, we go with 1 minus cosine theta over 2 under the radical. Okay, we use this formula and positive because it's the first quadrant. So 1 minus the square of 35/6 divided by 2, we are going to multiply by 6/6. And so what happens is that the numerator this becomes 12, and this becomes 6 minus square root of 35. So 6 minus square root of 35 remains, but what happens to 12? I want to show you here. Square root of 12 is square root of 4 times square root of 3, so it's 2 square root of 3. Please understand, the denominator class is 12, and it becomes 2 square root of 3. So that's the answer for sine of theta over 2. If you look at cosine, it uses exactly the same thing, but negative becomes positive. So all you have to do, because you work this, you don't have to do anything. Just write the same thing, change this to a plus sign. Again, why are we doing this? Minus sine for 1 minus cosine alpha over 2 for sine, 1 plus cosine alpha over 2 for cosine of theta over 2. So we calculated this. We don't have to worry about that. Okay, just change the negative sign to plus sign. We want to establish the last identity, cosine alpha plus sine alpha over cosine alpha minus cosine alpha minus sine alpha over cosine alpha plus sine alpha is 2 tan 2 alpha. We start with the more complicated side, which is the left-hand side, and we take a common denominator, which is cosine alpha minus sine alpha times cosine alpha plus sine alpha. When we write this, then this times this minus this times this goes to the numerator. Well, all you have to do, square this. First and foremost, the denominator class is cosine squared minus sine squared. That's very simple. This one, cosine squared plus 2 cosine alpha sine alpha plus sine squared minus, now this one is cosine squared minus 2 sine alpha cosine alpha and plus sine squared alpha. All of them take a negative sign. Please understand that cosine squared becomes minus cosine squared. Minus 2 sine alpha cosine alpha becomes plus, and plus sine squared becomes minus. Cancel out these two. Cancel out these two, and you're left with that. 2 and 2 add up to 4 cosine alpha sine alpha, and the denominator is cosine 2 alpha. So the numerator is, if we had 2, would be sine of 2 alpha. Since we have 4 of them, there are 2 of them. So 2 sine 2 alpha cosine 2 alpha. And I hope you recognize this as a tangent. So 2 tan 2 alpha. And that's the right-hand side. And that's the proof.